Perimeter, Area, and Volume, A Monster Book of Dimensions by David Adler, illustrated by Edward Miller. Have you ever been to a 3D movie? 3D movies look real. If there's a monster walking on the screen, it might seem as if he's walking towards you. As the monster on the screen gets bigger and bigger, it seems as if he's coming closer and closer. Such movies are called 3D because they seem to have 3 dimensions. They seem to have length, width, and depth. The 3 dimensions are sometimes called by different names. We might say something is tall, high or long, wide or broad, deep or thick. Whatever words we use, all things we can hold or walk around have 3 dimensions. Here are the monster stars of the movie Monsters in the Neighborhood. They're posing for a picture. Are they all the same size? Take a quick look. Only 2 seem to be about the same size. Some might be the same height, but not the same size. Height is just 1 dimension. Each monster has 3 dimensions. Each monster is tall or short. Each monster is wide or narrow. Each monster is fat or thin. To know how big something really is, you need to know all 3 dimensions. But sometimes you need to just know 1 dimension. In the movie Monsters in the Neighborhood, the monsters are bothered by nosy neighbors who run across their yards and look in their windows. The monsters decide to put up fences. Before they can buy the fences, they need to know how long each side must be. They need to know the total length of the fence around each yard. Length is just 1 dimension. Oh, those little purple monsters do look like they're having fun. Take a look at these 2 yards. One is bigger than the other. How much fencing would the monsters need for each yard? To find out, add up the lengths of all the sides. When you add up the lengths of each yard, you are finding its perimeter, the distance around. So let's take a look at house number 1. It is 60 feet wide in the back, 66 feet wide in the front, and 80 feet wide on both sides. 60 plus 80 plus 66 plus 80 equals 286 feet. Let's take a look at house number 2. It is 40 feet in the back, 42 feet in the front, and 90 feet on both sides. To find the perimeter, we add up all the sides. 40 plus 90 plus 42 plus 90 equals 262 feet. The distance around a circle is its circumference. To find the circumference of a circle, you first measure its radius. Radius is the length of a straight line drawn from any point on the edge of the circle to its center. Then you double its radius and multiply that by pi, which is about 3.14. So if we take a look at the circle the monsters have drawn, it is 25 inches from the edge of the circle to its center. Again, that's the radius. We take the radius, 25 inches, and double it or multiply it by 2. We also have to multiply by pi, which is 3.14, or 3 1400ths, which equals 157 inches. Look at the posters outside the movie theater. Each has a drawing of a monster. Do the monsters in the posters look real? It's difficult to make a drawing look completely real because real things have 3 dimensions and a picture has 2 dimensions. Pictures have just length and width. Pictures and the surfaces of flat objects have 2 dimensions. How big is the movie screen? If the side of each square is 1 foot long by 1 foot wide, the area of the square is 1 square foot. Count the squares. You are finding the area of the screen. I'll wait for you to count. Let's look again at the screen. It's a rectangle. It has 4 straight sides. Its opposite sides are the same size, and all 4 angles are right angles. To find the area of a rectangle, you multiply its length by its width. The length of the movie screen is 12 feet. Its width is 16 feet. Its area is 12 times 16. Its area is 192 square feet. Area measures surface. It's a 2-dimensional measure. Get a ruler or a tape measure and measure the area of this page. You can't really do that on the screen, so look at the ruler provided by the monster. It is 8 inches wide and 10 inches long. So we are going to measure the area of the page. We're just going to say it's 10 inches long and 8 inches wide. To find the area of this page, multiply the length by the width. Can you do that? 10 times 8 is 80. So the area of this page is 80 square inches. Square inches, square feet, square miles, square centimeters, square meters, and square kilometers each measure area. This book has 3 dimensions. The very top of this page to the book is the book's length. The left side of this page to its right side is the book's width. When you close this book and look at the pile of pages all bound together, you are looking at the book's 3rd dimension, its depth or its thickness. At the movies, you can buy a large box of popcorn or a jumbo box. Which box is bigger? That's easy. The jumbo box is bigger. What makes one box bigger than the other? One box is bigger than the other because it's higher, wider, or thicker. When any one of the 3 dimensions increases, the size of the box increases. Of course, when both boxes are filled, the jumbo popcorn box has more popcorn in it than the large box. Me, I love popcorn. I have to have popcorn no matter what when I go to a movie. We call the amount a box holds, or the space anything with 3 dimension takes up, its volume. The larger the box, the greater its volume. The jumbo box is 8 inches high, 6 inches wide, and 4 inches deep. To find its volume, multiply 8 by 6 by 4. The volume of the jumbo box is 192 cubic inches. The large box is 6 inches high, 4 inches wide, and 3 inches deep. To find its volume, multiply 6 by 4 by 3. The volume of the large box is 72 cubic inches. You can compare the volume of many boxes by measuring the 3 dimensions of each and then multiplying. A cube has 3 dimensions: height, width, and depth. So we measure volume in cubic measures. A cubic inch is a cube that is 1 inch high, 1 inch wide, and 1 inch deep. A cubic centimeter is a cube that is 1 centimeter high, 1 centimeter wide, and 1 centimeter deep. Cubic inches, cubic feet, cubic centimeters, and cubic meters each measure volume. Tonight is the opening night of Monsters in the Neighborhood. The monster stars and their families have come to the premiere. It's time for the pictures. The photographer tells the monsters and their families to line up. He wants short monsters in front and tall monsters in back. In lining up the monsters, the photographer is only interested in 1 dimension. He's only interested in the height of the monsters. It's starting to rain. The photographer puts away his camera. The monsters rush to get inside, but the door is not made for monsters. Some of them are too tall to get through. Some are too wide to get through. The door frame has 2 dimensions. It has height and width. Oh no, they're getting wet. Oh, but one has a cute little umbrella. Now it's time to go home, but it's still raining. There are lots of raincoats in lots of sizes. The biggest monster will need the biggest raincoat. The size of each monster is determined by how tall or short, how wide or narrow, and how fat or thin the monster is. Just to review our vocabulary real quick, because we learned a lot in this story. Perimeter and circumference are the distances around one-dimensional shapes. Area is the space inside a two-dimensional object. Volume is the space a three-dimensional object contains. Monsters and everything you can hold, pick up, or walk around have 3 dimensions. Now I need you to make sure that its length, and that's that first dimension those monsters talked about, I need you to make sure that the length is going to be about 9 inches. It doesn't have to be perfect, but we want our paper to have a length of about 9 inches. So using our one dimension that we know, the length of our shape, what can we find out? So we can determine the shape's perimeter. Perimeter is going to be the distance all the way around the edges of our shape. And our shape has a length of 9 for each one of the edges. So we have 4 edges. How do we calculate perimeter? Perimeter is going to be the sum of the sides. And we have 4 sides. So here is our formula. P is equal to S plus S plus S plus S, which designates our 4 sides. We can simplify this formula by saying perimeter is equal to, because I know that repeated addition is the same as multiplication, 4 times S, like this. I know that my side is 9 inches, so perimeter is equal to 4 times 9 inches. And what is 4 times 9? 4 times 9 is 36. So the perimeter, the distance all the way around our shape, is 36 inches. So when we're talking about perimeter and about our one dimension, I know that one side is 9 inches. So if I were going to travel all the way around my shape, I would be traveling a distance of 36 inches. So what can we figure out if we know 2 dimensions, if we know 2 pieces of information about our shape? Let's see. If I know 2 dimensions, such as the length and the width of my shape, I can find area. And area is going to be all of this part of my shape that is green on top, the 2 dimensions, the area. So I know that my length is 9 inches and my width is 9 inches. Do you remember the formula or the way the monsters taught us to figure that out? In case you don't, area is one of the simpler formulas we have. Area is simply length times width. So I need to multiply those 2 values. I know that my length is 9 inches. My width is 9 inches. So my area is simply 9 inches times 9 inches. Do you remember what 9 times 9 is? 81. Great job. So my area is 81 But what do I do with my units? Area is a square unit. So when I show you area, we talk about area being in square units. So my area is 81 square units because we have two of them, we're multiplying them together. We have two dimensions. That's how we find area. So we've talked about the easier ones. We've talked about if we know one dimension, we can find perimeter. If we know two dimensions, we can find area. But what about that third dimension? Hang on, we have some fun. So we've talked about what we can find out, characteristics of our shape with two dimensions. We talked about length giving us perimeter and length and width giving us area. But how can I take this flat piece of paper and give it some height so we can get that third dimension that we need to find volume that our monsters talked about in our story? Well, I have a treat. We're going to do a little bit of magic with this piece of paper, and I'm going to show you how you can turn this into a box. So we're going to have to be doing some folds, and I'm going to let you zoom in a little bit closer to see how we're going to fold that piece of paper to create a box. Fold that we're going to have to do to create our box to give this flat two-dimensional piece of paper some volume or some height is we're going to do a hamburger fold. So to do the hamburger fold, we're going to take the top to the bottom and we're going to put a really nice crease in our paper. Those creases are going to be important. It's going to be a guide for us in a minute. So after you've done your hamburger fold, we're going to go right to left and we're going to do a hot dog fold. And it doesn't have to be perfect. Okay, make sure you get that crease nice and good. All right, so now you should see that your piece of paper has 4 squares. We're going to zoom in a little bit closer for the rest of this. Come on. So now we've used that hamburger and hot dog fold to make 4 squares. What we need to do now is take each corner of our square into the center and make some triangles. Remember to crease those edges. So what we're doing is we're taking each corner into the center. We've done 1, let's do the other 3. Kind of reminds me of a pizza box that we're making. So as you can see, we've now taken all 4 corners into the center of our square, and we've actually made a smaller square. Now that we have them in the center, this is the most complicated part. The next fold that we're going to do is we're going to fold it into 3 equal pieces, and we're going to do those hot dog folds, doing it into the center. So we're going to take this side into the center, and we're going to do it about 1/3 of the way over. Let's tuck that in under. Let me do the crease for you, and I'll show you what this is going to look like. Here you go. We have this side turned in. That's 1/3. Now we're going to fold the other side over. So it kind of makes one of those trifolds that you may have done in your classroom. Now that we've done it, using the right and the left side, we're going to open it back up, we're going to turn it around, and we're going to do those other sides. So let's do one more fold in thirds. So we're just going the other side, folding it into thirds. So we're doing the same thing we did, just having turned it a little bit. So what happens when we open it up? Let's see. So I want you to open it all the way, and you can see that you have some squares and some triangles just from the folding pattern. So what we're going to do is we're going to now create the box. So what I need you to do is I need you to take 2 of the corners and fold them into the inside like this. And where they meet in the center, this is actually going to be the bottom of your box. And then you're going to take these 2 corners and fold them in. The right corner is going to go here to the top, like so. The left corner is also going to go over to the top, and you can see that we're starting to make our box, and then we just take this top and we tuck it in. So we have the start of a box. Let's do the other side. Again, these two corners are going to go into the inside, so we take this top corner, we're going to fold it in. This other corner, we're going to fold it in, and can you see our box? Great job. And we take and we tuck it in. So we have now taken a flat piece of paper with two dimensions, length and width, and we've created a box that now has height. So do you remember what the monster said? What can we figure out characteristic about the shape we have if we know 3 dimensions? Do you remember our vocabulary word? Volume. Great job. Well, our paper's size has changed a little bit when we folded it. So now we need to figure out the measurements. Let's give it a try. Now that we have some height added to our length and width for our box, what can we do with our 3rd dimension? Do you remember that vocabulary word the monsters talked about? In case you don't, I'll give you a hint. It started with a V. Volume. Great job. To find the volume of our box, and by volume we're talking about how much space we have inside of our box, we need those 3 dimensions. We need length, we need width, and we need height. So we're going to use our ruler and we're going to measure to the closest inch. It doesn't have to be perfect for what we're doing. And as you can see, the length of our box is going to be approximately 2 inches. Our width is also going to be 2 inches. Those are our 2 dimensions that we had that gave us area. But now we also need height. We need to know how tall our box is. And our box is about 2 inches tall. So our 3 dimensions are going to be length, width, and height. That's what's going to help us find the volume of our box. So the formula for the volume of our box is length times width times height, using all 3 dimensions. What was our length? Great, 2 inches. What is our width? Also 2 inches. Do you remember that height? Great, 2 inches. So volume is going to be 2 inches times 2 inches times 2 inches. 2 times 2 is 4. 4 times 2 is 8. So our volume is 8, but what about our unit? Volume is a cubic unit. We have 3 inches that we used as dimensions. So we're going to say that our volume is 8 cubic inches. Great job. I hope you had fun learning about perimeter, area, and volume. And you got a great box too.